Let's look at some composition of functions. So let's start with looking at f of x, which is 3x plus 4, and g of x, which is 2x minus 7. So we have two linear functions that we're going to compose together. First thing that we're asked about is f of g of negative 1. I prefer to write it as f of g of negative 1 because I think that's helpful to see which piece to do first. So first I'm going to grab my calculator and plug in and figure out what g of negative 1 is. So looking up at g of x, I'm going to do 2 times negative 1 minus 7. So calculating g of negative 1, I have 2 times negative 1 minus 7, which gives me negative 9. So I'm really doing f of negative 9. And now I'm going to go into the function f of x and plug in negative 9. So I'm going to have 3 times negative 9 plus 4, which gives me negative 27 plus 4. I'm getting negative 23. So you plug into the inside piece first and then to the outside piece. Let's compare that if we go the other way. G of f of negative 1. So what does that mean we're starting with? We're going to start with f of negative 1. So I'm going to go f of negative 1. I'm looking at the function for f, which is 3 times negative 1 plus 4. So 4 minus 3 is just going to give me 1, which means to do g of f of negative 1 really means I'm doing g of 1, since that's what f of negative 1 is. So then I can go into g and plug in 1. So g is 2x minus 7. So I'm going to do 2 times 1 minus 7, which is negative 5. So not too bad you're evaluating functions, just pay attention to the order, because like we saw in this one, the order did matter. Doing f of g of negative 1 got us negative 23 versus g of f of negative 1 gave us negative 5. So order does matter for these. Let's find formulas instead of just evaluating for f of g of x and compare it to g of f of x. See what we get for both. So first of all, I'm going to do f of g of x, which means I'm going to replace each x in f with what g of x was. G of x was 2x minus 7, which means I'm going to go in and replace each x with the 2x minus 7. Now we're used to replacing numbers, right? We plugged into f a couple times. We replaced x with a negative 9. We replaced x with a negative 1, and that was fine. Now we're going to go in and replace that 3. Instead of writing x, we're going to replace it with 2x minus 7 plus 4. So we still have 3x plus 4, but we're replacing x with g of x instead of just a number. So I need to distribute this here. My f of g of x is going to be 6x minus 21 plus 4, which really means that f of g of x is 6x, and then negative 21 plus 4 gives me a negative 17. So when I don't plug in a number, I don't get a number. If I plug in a function, I get a function. So a number would give me a number, like we did f of g of negative 1, we got a number out. But if we do f of g of x, if we plug in a function, we're going to get a function. Working the other way, if I do g of f of x, I'm going to go into g and replace each x with what f of x was. So I'm going to go into g and replace x with a 3x plus 4. We've plugged into g a couple times. We've already plugged in g of negative 1. That meant replacing x with a negative 1. We did g of 1, which meant replacing x with a 1. Now we're going to go into g, that 2x minus 7, and do 2 and replace that x with more than just a number. Instead of 2x minus 7, it's 2, and I'm replacing x with a 3x plus 4. I'm going to distribute in here, which is going to give me 6x. 2 times 3x is 6x, and 2 times 4 is 8, minus 7. So my g of f of x, when I combine my like terms, I get 6x plus 1 when I do 8 minus 7. So did f of g of x equal g of f of x? Well, f of g of x was 6x minus 17, g of f of x was 6x plus 1. So to put it simply, no, they are not equal. The order in which we composed them determined our answer. It was not the same answer for either order, which made sense because we didn't get the same number when we switched the order earlier. So when we plugged in -1, the ordered mattered, and also when we plugged in x, the ordered mattered. We got different answers for doing f of g compared to g of f.